Hello, everyone. Welcome. Thanks very much for joining us today for the Mathematics Pedagogy, Rigor, and Engagement webinar. My name is Anita Thompson, and I am the North American Sales Executive for Matific. And it is my honor and pleasure to introduce Matific's co-founder and Chief Learning Scientist, Professor Raz Kupferman. Raz was formerly the chair of the Einstein Institute of Mathematics, head of the Middle School Mathematics Curricular Committee. He's the author of Elementary School Mathematics for Teachers and Parents, and inaugurated a professional development program in math for primary teachers. Lean in and enjoy. I guarantee you'll learn something in the next hour that you can immediately apply to your classroom teaching practice. Without further ado, I pass you over to Raz. Over to you, Raz. And I'll meet you on the other side for the Q&A. And please remember to post your questions. Thanks so much.
Thank you, Anita, and hello, everybody. I will share my screen now. All right. So, and of course, any question, I'll be very happy to reply at the end of my lecture. So maybe just a few words. I was presented. So I'm indeed, my real profession is being a professor of mathematics at the university. So I do research and I teach students. But maybe my real passion has been education for many, many years, and I've been involved mainly with primary school math education. And I'm going to talk now about pedagogy, basically, which is indeed my passion. All right, so that's a very familiar picture. I want to open my lecture by giving a very concise example of how we as a community things wrong. And so let's take the subject of the area of a triangle, something which in most countries is being taught somewhere between grade 3 and 5. Students learn that the area of a triangle is given by a formula, the length of the base times the length of the height. You multiply them and you divide by 2. And then next thing, you get questions, word problems, as we call them, right? The triangle is 10 centimeters wide and 6 centimeters high. What is its area? And then a tricky question, it's 8 centimeters wide and its height is twice as long. What is its area? And as a mathematician, what I really want to tell you is that this has nothing to do with mathematics. Okay, we're just training human robots to plug in numbers into formula don't understand, and they certainly don't see the purpose of doing that, and they're right. So, of course, the question is, all right, what's the alternative? Aren't we supposed to teach about the area of a triangle as well as other shapes? So let me just give you a glimpse of an alternative. So first, we're talking about geometry. So we're talking about shapes, and I would like children first to see shapes, play with shapes. We have today so many resources that allow us to manipulate shapes, for example. So what I'm doing here is just moving the tip of the triangle. And then at some point, maybe a teacher, maybe some other resource could draw this dashed line. And all of a sudden, you see something new. You may see this. Okay, you realize that the blue area, which is the area of the triangle, equals the yellow area, which completes the triangle, into a rectangle, meaning that the blue area is 1/2 of the total blue plus yellow area. And the thing is that once you observe that, you can no longer unsee it. It just haunts you, right? You keep seeing that all the time. And that's the explanation, right, why the area of the triangle is 1/2 the area of this rectangle, which happens to be the product of the base and the height. All right, now that's understanding. That's understanding the ideas and the reasons why things are the way they are. So as I was saying, my passion is education, and I've been involved for many years now in math education, including through Matific, about which you will hear later on. I'm really going to talk about pedagogy, but I want to say a few words about my vision in how to, what I want to contribute to education. So I really expect turning the making of mathematics into an exciting, playful, intellectual journey. And most people hear that, it seems as remote from their own mathematical experience as students and later on as parents, as teachers, and so on. I want to reveal the power of mathematics as the art of discovering and applying those discoveries in real and fictional settings, develop in every child a sense of capability, which, together with their natural curiosity and playfulness, will result in a no problem is too hard for me attitude, cultivate critical thinking, and finally bring the highest possible mathematical education to every child around the world. Now, these are great words, and the question is how to do it. And in this lecture, I will try to show through examples. It will all be examples how to combine pedagogy, so really deep mathematics, and engagement, so that to engage children into doing real, meaningful mathematics. The first thing I want to talk about is promoting conceptual understanding. So, we all agree that understanding the concepts is the key for us for a positive attitude towards mathematics, and all those things. I was talking about the no to problem is too hard for me attitude. Understanding the concepts is what will eventually lead children to STEM disciplines. But yet, when you open almost any resource, it could be textbooks, it could be online resources, what you see is all the time this overemphasis of procedures. And let's see an example. And the example will come from very elementary topic, usually taught in grade 1, odd and even numbers. So let me ask you, the audience, which I unfortunately don't see in person, what is an even number? I could provide you with 3 different answers. It's a number, it's a whole number that sums 2 equal wholes. So 6 is even because it's 3 plus 3, the sum of 2 equal wholes. But it's also a number summing a collection of pairs. So under this angle, 6 would be even because it's 2 plus 2 plus 2. But here is a third answer. It's a number whose last digit is either 0, 2, 4, 6, or 8. Now, the first 2 answers are really the essence of parity, whereas the third is purely procedural and in a way an accident just because we happen to use a decimal representation system. It would not be true if, for example, we were using a base 5 system. Now, you open a book, you open all kind of online resources, and what you see is basically what you have now in front of you. A list of numbers, and you're supposed to mark or color or whatever engaging activity, the even numbers or the odd numbers, and it just trains you to follow procedures. So let me show you an alternative. So what I'm going to show now is a mini game designed for children at the age of 6, 7. And here's the game. You got a flock of funny birds, and you're asked whether the number of birds is odd or even. Now, of course, you could count the birds and then look at the 1 digit, but that's not the point, right? You actually birds, and you can start now to manipulate them. In all those activities, okay, everything can be manipulated. For example, you could form pairs and then discover that you have one that's left alone. Okay, so it's hands-on experience with the concept of odd and even numbers or odd and even quantities. That's already more challenging, right? It's actually not that easy. So again, you could try all kinds of manipulations, right? For example, take those 2, and now somehow you can convince yourself that they're all paired together. So it's just an example, okay, of an activity for little children that really tries to concentrate the essence of being odd or even, and think how different that is from just identifying the 1 digit of a number. The next thing I want to comment on is engagement. So right now, the entire community talks about how important it is to engage children, not only in mathematics, of course. In mathematics, I have a feeling that a lot of what we do is actually counterproductive. And I really worked both with children and teachers for many years, and parents. And what I see are two, I think, very negative actions. One of them is overprotection. Okay, because this feeling that children are frustrated, we tend to overprotect them. We don't want them. We are actually avoiding the challenge. Everything has to be easy. Just think of how many ads you've seen of making math easy. And I'm claiming that making math easy conveys a message to the child: you're not smart enough, so we'll make things easy for you. And the other one, which is closely related, I think, is sugarcoating, okay, which is what I would call fun out of context, which also conveys a message that math is boring, so let's try to find the fun elsewhere. So let me again show an example, okay? And what I want to talk about now is how to combine the rigor with the engagement so that the fun is the mathematics. The fun is not an additive, right? Some sweetening to the mathematics. The example now will come from using a number line model to add and subtract numbers, in this case, numbers up to 20. What you see on the screen is a typical textbook question. Yeah, you have to evaluate the sum of 4 plus 2, and you have this number line model at your disposal. You can put your pencil on 4, jump 2 notches to the right, land on 6, and get the answer, which I must say, it's only it's not a crime, right? But I want to show you how to gamify this learning objective in a way that the game is the mathematics. So here it is. So what do we have here? We have this crystal ball, which if I let go will fall and break. There's a net here, and my goal is to place springs on this rail so that the ball lands into the net. Now that was very easy. There was just one spring, not much to do. Of course, I first want the child to understand the mechanics of the game. But now comes the next question, and I have now more springs. Some of them will cause the ball to jump to the right, forward, or backwards. And what I need to do is to eventually lead the ball into the net. Okay, so that would be a solution. Sorry, that would be a solution. By the way, the child may start to play with that and maybe realize there are more solutions like this one. Okay, now again, it's a game. Think now from the point of view of the child. It's a typical game where there's a task, and you may, of course, if you don't do it correctly, you lose lives or whatever, you lose points. But now think of it as an educator. The task really is to do addition and subtraction on the number line. So the fun is the mathematical task and not something which is an additive to it. Okay, so it's just, again, one example of gamification which does not overshadow the learning objectives. The next thing I want to discuss is natural mathematics. So we hear so much that children feel that math has nothing to do with their lives, irrelevant. And I must say that to a large extent, the math they're being taught by the programs we write is not very relevant to their lives. So part of the challenge is to bring math closer to the life, because the mathematical intuition, which is so critical for a solid mathematical background, comes from a combination of what we learn with our everyday experiences. So here again, I will just show an example, this time from a more advanced topic, which has to do with the product of fractions and whole numbers. So the setting here is some kind of baking game, like a TV show, Bake It. All right, yes, that's the Swedish cook, I guess. All right, so that's us, right? We are the player. We have to check whether all the ingredients are there. Check if there's missing oats, for example. And then comes the task. You see that the recipe has a third cup of oats for every serving, and we have to make 4 servings, and we have oats, we have a measuring cup, a measuring spoon, and we do actually, we are simulating real-life operations of cooking, right? And that's an example. Again, one for Matific probably has something like 1,500 mini games like that, in many of which we create settings from real life settings, which are part of the game, in which children can actually do mathematics within real life settings. So the end of the game, I will skip here because our time is somewhat limited, is that if you do it right, the cookies have a good taste, and there's a contest here, but I will get now to the next topic. Learning by doing. So I don't know if Confucius really said that. What I hear, I forget. What I see, I remember. What I do, I understand. But what I certainly know is that research in education shows consistently that active, hands-on learning is the most effective way of learning, certainly compared to any form of passive learning. So it means that when we want to engage children in any activity, it has to be as hands-on as possible. It just leaves a much stronger impression on their brain. So again, an example. Again, from the primary school curriculum, no matter in which country, at some point you're supposed to name shapes. Like you have this yellow shape here, and it could be described by more than one name, right? It's not a rhombus, but it's a quadrilateral because it has 4 sides. It's not a square, but it's a rectangle. So again, it's a typical textbook or online resource question. And I want to show you how to turn the identification of shapes into something so much more active. And what I want to show you here is a kind of digital lab where you have shapes and scissors and glue. So for example, in this first question, you have this pentagon and you have scissors, and you're being asked to create a trapezoid and a triangle. Now, on my computer right now, it will not show, but on the actual site, if you click the word trapezoid or triangle, it will show you several examples so that, if you haven't learned, you can have a quick reminder or look of what it looks like, right? But by the end of the day, what you're supposed to do is to, in this case, use the scissors to do whatever you were asked to do.
Make 2 trapezoids and 1 rectangle. Use all shapes.
Okay, let me skip quickly to the third question. But again, the child actually has to make trapezoids and not just to identify it, right? Remember, I'm right now talking about active learning. And in the third question, if I remember correctly, right, I have glue now.
Use all shapes.
And I'm supposed now to make a trapezoid with 3 triangles. It becomes quite complex at some point. This one is still not too hard. But then later on, you get already combinations of glue and scissors, and questions can become quite intricate. Okay, we made trapezoids. So that's an example of how I turn the topic of describing the names of shapes into something which is far more active than the typical identify the shape task. The next thing I'm going to describe is problem-solving skills. So open almost every curriculum in every country, and you will see the obvious, right? We are teaching mathematics. Children are learning mathematics not just for the sake of repeating what they've learned, but for developing the ability of solving new problems they haven't seen before, using the knowledge, the techniques, the skills, the strategies that they have acquired. So basically, doing problem solving is a very important task, right? You want to present children with something that maybe in the beginning they don't know how to approach, and somehow lead them into attacking it, trying different strategies, and so on. That's what doing mathematics really is about. Now, but teaching that is very, very difficult. First, even finding problems that are adequate for this kind of problem solving in class, they're very hard to find, okay? And not to speak to, throughout the year, to do many activities of problem solving. And also remember, I was talking about this sugarcoating and overprotection. Doing real problem solving actually requires you to, at some point, frustrate the learner. Okay, they have to get stuck so that they, they can get out. I mean, that's what we want to teach them, right? Get stuck and learn how to get out of it. And a lot of teachers, very often tend to give out the solution way too early. Now, what can we do about that? So I claim that through gamification, it's quite easy to engage children into do real difficult problem-solving activities. Children are used to games. They're used not to always succeed. When they fail, they don't have a feeling of having failed. Very often they're just motivated to retry and pass the stage at which they failed previously. And let me show you how we can do with fourth or fifth grade children real difficult mathematics in a way which is certainly not threatening to them and develops very nice, what I would call pre-algebraic skills. So we'll do algebra without algebraic notation. Here it is. It's a multi-level game. And again, the age group would roughly be 10, 11, 12. So as usual, the first question is easy because I just want you to understand the mechanics of the game. I don't know if you remember the first Indiana Jones movie that starts with Indiana Jones replacing something he's stealing from a cave by something having the exact same weight. That's the game here. We, the monkey, we have to steal the ring. The gorilla is asleep guarding the ring. And as long as we keep the scales balanced, the gorilla will not wake up. Now we have to replace the ring with hearts, red hearts, and put the right quantity so that they balance this yellow brick. So I go to the side and I see that one yellow brick has the same weight as two hearts. So I can go back and this monkey with two red hearts and tell the monkey, switch. We did it. Okay, that was easy. Level 1. Let's go to level 2 now. All right, so same problem. Steal the ring. This time the ring is being balanced with this, it's another ring, with this blue shade. And when I go to the side, I actually have two equations in how many? 3 unknowns, right? See, what I see, I'm talking algebra, but from the point of view now of the player, of course, I see that one purple brick is like two hearts, and a purple and two hearts is like one blue. So of course, you could do the math in your head, but we could also play the game like a child would. If I see that one purple equals two hearts, I can do what in algebra we would later call a substitution. We can substitute the purple weight with two hearts without without breaking the balance. So it's a substitution so that the equality in algebra remains valid. And now I see that blue equals 4 hearts, and I can replace the ring with 4 hearts. Now, if I remember correctly, let me actually exit just because it's too much noise. If I remember correctly, this game has something like 32 levels, and it becomes increasingly hard. Okay, at some points, you have many equations, many unknowns. Again, there are no equations, no unknowns. You have scales, you have weights, and you can do all the algebraic operations of adding the same weight to both sides, removing the same weight from both sides, and doing a substitution. You replace something by something else having the exact same weight, which you learn from just looking at the other equations, the scales. Okay, and again, I claim that children already at grade 4 could do quite difficult algebra, maybe something that 2-3 years later they would experience extremely hard, but it's a game. And I observed children around the world playing such games, and the motivation is amazing. The motivation you would never see them when learning algebra 2 or 3 years later. Okay, so I really claim that you could do deep mathematics at almost every age if you just give the right setting, the right non-threatening setting. A few words about what I would call feeding ahead. Math anxiety, a big international cross-cultural problem. So much has been written about that. I think that to a large extent, this anxiety is caused by the fact that children learn something at a very rapid pace when they don't have the right preparation to it, and then they just have to survive. I think that many of us, think back at our student years, remember this feeling of survival, right? So there's a lot of material, I don't really understand it, but I have somehow to pass the test, so I don't want to understand. Just tell me how to do and not what it means. And a lot of that can be remedied by preparation ahead of time, what I call seeding ahead. Just think about how so many children start grade 1 or even kindergarten when they already have several years of exposure to numbers, to counting, and how different it is, right? How naturally they can blend into the early grades. But then at some point it breaks because you don't have the right preparation. So I want to show an example how you could do with, grade 3 children, play with negative numbers, even though it may come much later in the curriculum. In my country, you start to learn negative numbers in grade 7. And yet, I claim that you could learn so much and experience so much about negative numbers long before. So what you see here is this funny hotel on a cliff. And the entrance floor is floor 0, level 0. And as you will see now...
Good morning. The elevator is out of order today. But that won't keep our hotel from providing excellent service, the best in the country. Did you hear that? No elevator. Could you help me give our guests the best service possible?
Sure. Okay, so the player, the child...
A guest on floor minus 12 has just ordered lunch. How many floors should I go down to get there?
We're on floor 0, and we have to go to floor negative 12, so it's not very difficult, right? Although, again, me as a player, I can actually browse this hotel. I could go down and up. Okay, remember that a good game should enable you to manipulate as much as possible. All right, so the answer is 12, right? So let me, spoiler alert, the answer was 12. and we go down 12 floors, no elevator, right? That's the problem.
A guest on floor 8 needs you to pick up some dirty dishes. How many floors should I go up to get there?
All right, so we have to go, we're at negative 12, we have to go to positive 8, and the question is how many floors? So again, I can actually count, right? I could really go up floor by floor and count, or I could start to reason that I have to go back to floor 0, it's 12 floors, and then I need to go up to floor 8 and do the math. Let me actually make errors. I haven't said a word right now about what happens when you do. Okay, so first, when I make an error, I actually want to see what the implication is. So I wrote 13, I get to floor 1, and there's an...
I guess this is not the right floor.
Right, the customer is very unhappy. I got it.
How many
so
floors
that's
should I
something
go up
very
to get there?
important.
A guest on floor 8 needs you to pick up some dirty dishes.
When children make errors, it's very important, whenever possible, that they see what the implication of the error is. Not tell them that it was an error. We'll come to it in a moment, okay? So let's go up, I don't know, 14 floors or something. I'm making errors on purpose right now.
I guess this is not the right floor.
What I wanted to show you here is a first example of how to provide
How many floors
feedback.
should I go up to get there? A
Here.
guest on floor 8 needs you to pick up some dirty dishes.
Yeah, you see the diagram here, right? So after 2 errors, I'm showing the child already. I'm not giving the answer, but at least I'm showing some diagram that may hint, give a direction how to think about it, right? So, how many floors going up from negative 12 to plus 8, placing 0 in the middle, and okay, just so that we're happy at the end. Let's give the right answer. Yes, everything's okay. We can go back to the presentation. So the last topic I want to talk about is indeed feedback to errors. And again, I talked already about overprotection and so on. I'm a mathematician. I can tell you one thing for sure. You cannot learn mathematics. You cannot not learn anything, I guess, without making errors. You learn so much from your errors. And if you don't never make errors, it means you're not challenged enough, and your learning is not efficient in a way. And the big question, of course, is how to respond to errors. And the approach that I always try to promote has several components. First, making errors is not failing. It's just a natural part of any learning process. Secondly, I describe it here as being accountable to your errors. I mentioned that with the hotel, right? You made an error, let's see what happens, okay? If you think that's the answer, let's see what are the implications. I want you to discover the fact that you made an error, not because me or your teacher or the computer tells you it was wrong, but because you see that it leads you to something wrong. And finally, we know as teachers that our feedback has to be as informative and personalized in the fact that it really, it's wrong, but we explain as much as possible how, in what sense it's wrong. And the last example will come from the end of the year recital. The topic is around year 4 or 5, having to do with common multiples of numbers. So we, the player, help the choreographer. All right, the first task is to drag some monsters to the stage so that they can dance in groups of 2. Let's do it, I don't know, that should be fine, right? So 6 is a multiple of 2, right? I was talking about common multiples. So there's nothing common here right now, just a multiple. The next task, I have to drag the monsters to the stage so that they can dance in groups of 3. 6 is still a good number. But the third task will be already more complex. I need now to drag monsters so that they can first dance in groups of 2, but then the same group can change into groups of 3. Okay, so you identify the common multiples, and now let me make an error on purpose. Let me say drag 10 dancers. That will fit for the first part of the task, but then of course it will fail on the other one. Let's see what happens. So they dance in groups of 2, and then they rearrange, but there's one monster crying because it doesn't have 2 other monsters to pair with. And then I get, so first I was talking about being accountable for your errors. I made an error and I see the implication. On the second part of the show, there's one monster left without having a triple to join. And then I also get informative feedback. It's possible to divide 10 dancers into groups of 2, but not into groups of 3. Try making a group with a different number of dancers, okay? So that's what I wanted to show through an example how I can first let the child see the implication of the error, and secondly, get informative feedback, which is specific to the error the child has made. And finally, I hope it's clear that it's a non-threatening setting. I don't think the child feels frustrated from not having succeeded. Got it. All right, thank you very much for your attention, and I'll be more than pleased to answer any question you may have. Thank you very much.